On January 19, 2006, NASA launched a spacecraft the size of a baby grand piano. It was moving faster than any man-made object had ever moved. It crossed the moon's orbit in 9 hours. That same trip took Apollo astronauts 3 days. And then, for 9 years, nothing. Just a probe hurtling through absolute darkness toward a world we had never once seen up close. Then, on a Tuesday morning in July 2015, the pictures started coming in, and everything we thought we knew about Pluto collapsed. Pluto was discovered in 1930 by a 24-year-old from Kansas named Clyde Tombaugh. He'd been scanning photographic plates for months, looking for a faint wobble in the outer solar system that astronomers had predicted must be there. On February 18th, he found it, a tiny, shifting dot. The solar system suddenly had a 9th planet, and for 76 years that's what it was. Nobody could see it clearly enough to know what it really was. Even Hubble, when it turned its eye toward Pluto, 1990s returned images so blurry they looked like a smeared thumbprint. We knew it existed. That was about it. Then came the vote. In August 2006, the International Astronomical Union gathered in Prague and did something that made headlines around the world. They stripped Pluto of its planetary status. Just like that, the solar system went from 9 planets to 8. Millions of textbooks became wrong overnight. Here's the part that gets overlooked. The New Horizons probe had already been in space for 7 months when that vote happened. It had launched in January, aimed precisely at a world that, by August, was officially no longer a planet. The mission kept going. The probe kept flying. For 9 years, it flew toward a place most people had decided wasn't worth thinking about anymore. But the scientists who built it knew something the voters didn't. They knew that Pluto, whatever it was called, was somewhere we had never been. And the universe doesn't care about our categories. Between 2006 and 2015, New Horizons was essentially alone. It passed Jupiter in 2007, using the giant planet's gravity to slingshot itself faster, deeper into the outer solar system. At that point, it was already farther from Earth than most spacecraft had ever gone. After Jupiter, there was nothing, just the Kuiper Belt stretching out like a frozen ocean. No planets, no waypoints, just distance. The probe spent most of those years in hibernation. Its instruments powered down to conserve energy. Mission controllers would wake it up occasionally, run diagnostics, then put it back to sleep. By the time it was approaching Pluto in early 2015, something had already shifted. The images it was sending back were still blurry, but they were getting sharper every week. And in those blurry frames, scientists started seeing something they hadn't expected. There was a bright region, a big one. On the left side of the planet, something was reflecting light down there, something huge. July 14th, 2015. New Horizons had 9 hours. That's all. It couldn't stop, couldn't orbit, couldn't circle back. The physics don't allow it. It was moving at 31,000 miles per hour, and the only way to slow it down would have required a fuel load heavier than anything we could have launched. So it flew past Pluto at 31,000 miles per hour. Instruments spinning, cameras firing, capturing everything it could in one single pass. The closest approach happened at 7:49 a.m. Eastern Time. At that moment, New Horizons was 7,800 miles above Pluto's surface, and then the probe went silent. Not broken, silent by design. During closest approach, it was too busy collecting data to communicate with Earth. For 13 hours after the flyby, Mission Control heard nothing. When the signal finally came back, the room erupted. Then the images started arriving, not all at once. The transmission rate from that distance is brutally slow, about 1 kilobit per second. Downloading the full dataset took 16 months. But what they could already see, even in those first frames, was extraordinary. Pluto had mountains, real mountains, made of water ice standing 3.5 kilometers tall, higher than the Rockies. It had a smooth, pale plain the size of Texas, completely devoid of impact craters, which meant it was young, geologically young, active. A world that supposedly had no internal heat source was somehow still reshaping itself. Nobody had predicted any of this. Start with the heart. Scientists named it Tombor Regio, after the man who found Pluto. It's a vast nitrogen ice plain, shaped, genuinely, unmistakably shaped, like a heart stretching nearly 1,000 miles across. The western lobe, called Sputnik Planitia, is so smooth it looks polished. Geologists studying the images found almost no impact craters on it, which means the surface is being actively renewed. Something below it is churning. The leading theory involves nitrogen ice convection. Slow, churning cells turning over like a boiling pot of oatmeal, but over millions of years. The heat driving that process might come from the decay of radioactive elements deep in Pluto's core. But here's what makes scientists uncomfortable. The heart is locked in place. Pluto's rotation has been influenced by that massive bright region in a way that suggests it's sitting directly on the tidal axis. The heart may have essentially reoriented the entire planet around itself, a geological feature so massive it redirected a world. Then there's what might be underneath. Beneath Sputnik Planitia, models suggest there may be a liquid water ocean. Not at the surface. Pluto's surface temperature is around -230 degrees Celsius. But deep underground, insulated by the planet's own rocky shell, kept warm by radioactive decay, there may be water that has never frozen. We don't know. We genuinely do not know. There's no orbiter up there, no probe drilling into the surface. The evidence is gravitational, the way the planet moves, the way the ice plane behaves. And it points toward liquid water, on Pluto. And then look up. Pluto has a haze, not a smear, not a glow. A structured, layered atmospheric haze with at least 12 distinct bands stretching up to 200 kilometers above the surface. The haze scatters sunlight in a way that makes it appear blue when backlit. Pluto has a blue sky. The haze is made mostly of tholins, complex organic molecules that form when nitrogen and methane get hit by ultraviolet radiation. Those same compounds have been found in the atmospheres of Saturn's moon Titan, in comets, in interstellar clouds. Tholins are considered potential precursors to life. We found them on a world we barely looked at for 85 years. New Horizons is still out there, past Pluto now, billions of miles beyond it, continuing deeper into the outer solar system. It has enough power to keep transmitting until around 2038. But it's not going back. We have one dataset, one pass, 9 hours of close observation across 9 years of travel, and we came back with questions we don't know how to answer without going again. The subsurface ocean, real or not? The heart, why there? Why that shape? Why so young? The haze, what exactly is forming in those layers? The methane ice mountains of Tartarus Dorsa, how did they get there? A Pluto orbiter has been proposed. Concepts have been drawn up. Arguments have been made. Funding debates have been had. None of it has launched. We live in a solar system that still has secrets. Pluto isn't an exception to that. Pluto is the proof of it. We looked at it once, for 9 years of travel and 9 hours of data, and we haven't stopped asking questions since.